My research concerns the study of the most massive stars in our galaxy and in local group galaxies. We study stars that are maybe 30, 40, 50 times more massive than the Sun. Our exploration, our understanding of the solar system, this is part of astrophysics. The fact that we find more water on other moons around, say, Jupiter than there is on Earth is very, very significant. You can't get away from it. We've all been watching, presumably, Blue Planet 2 recently, and you see these submersibles going to great depths, in depths of oceans where there is no light, very hostile environments. Well, how much more hostile can the oceans underneath some of these moons of Jupiter be, really? Right? So there is this tremendous opportunity to understand life processes through astrophysics. And then we're also discovering thousands of planets around other stars now. These are these exoplanets. We're on the verge now probably of picking up, we're seeing more and more Earth-like planets. We're going to find Earth-like planets that are in their own habitable zones in and around their stars, raising the interesting possibility that there again there could be the ingredients that we associate that you need for life and the biosignatures for that. So I think there's just such a tremendous range of topics covered by astrophysics that I think is a tremendous, it's a great interest, I think, to public. I'm not sure about colonizing Mars by 2024. If we even manage to get something launched by 2024 that can help us to start to explore the idea of establishing bases there, that I think would be a tremendous achievement in itself. But I think the drive is very important. The idea that we should be exploring further and be more ambitious in our solar system exploration is very, very important. I think it's part of what humanity would be interested in. Most recently, the stunning detection of gravitational waves. It confirms Einstein's theory of general relativity. Right? The idea now that how do we get these gravitational waves? We're getting them from the collision of 30, 40 solar mass black holes, for example. These black holes are the remnants of massive stars from colliding neutron stars recently, where the electromagnetic light was also seen to travel and arrive at the same time, showing that these gravitational waves do indeed travel at the speed of light. So I think this is a very, very significant development. It is opening up a whole new window of observing the universe, and there is a tremendous potential. I think there's life elsewhere in the universe. By life, it may just be bacterial life, but again, I'm very, very inspired by Blue Planet 2 to some extent. When I see the environments in which life exists, it's just so bizarre, right? Why? Well, I mean, if you just look at the statistics of this, right? We have 200 billion stars in our own galaxy, right? We have billions and billions of planets in our own galaxy. There's no doubt about that, right? The probability of having planets that are in habitable zones is very, very high. So I think the chances of simple microbial life is very high. The evolution of that to something more sophisticated and multicellular is perhaps more challenging to answer. That I wouldn't be sure about, of course, at all, but it wouldn't surprise me.